everyone. Today I want to talk about my new project, SHSM. This video or content was made primarily from a viewpoint of budget or hardware constraints. One can use it as a reference in situations applicable. This content, if it's geared towards China, then some parts will be applicable to Tencent, Baidu, Ruijie, and Alibaba. If it's geared towards Malaysia, then it may be applicable to Western blockchain consumption, payment gateways, cloud API consumption, networking devices, cloud API and native API consumptions, and big tech companies' cloud API consumptions. If the service provider is password manager, it may also be applicable to them. Hardware security module is a specific piece of physical cryptographic security module that aims for specified parties such as military, confidential government agencies, national defense, certificate authority, e-commerce, platforms that provides financial cards binding features for users, and big multinational corporates. Its main purpose is to allow long-term use of cryptographic secret and private keys in a secure manner during runtime. Some traditional providers include YubiKey and Tails. The reason behind the reliance of HSM device is the use of such device prevents any alterations and theft of private and secret keys during long-time usage of them. Although HSM device offers great security, often the case, SME finds the cost too expensive. The situation worsens if the users were not coming from Western nations as their currency conversion rate. SHSM stands for Software Emulated Hardware Security Module. From the viewpoint of actual PKIC experts, the term SHSM or VHSM or Secure Key Management may not be applicable or accurate. For my own viewpoint, there are no other and better terms to describe other than one of the stated terms above. Traditionally, SHSM was used either for testing purposes or in use cases where actual HSM devices were not available or applicable. It was not a replacement to HSM because of it can't prevent virtual and physical theft of private and secret keys. The development and use of SHSM was not to replace HSM, as the security guarantees of HSM is always better than SHSM. It serves as an engineering alternative under applicable situations. The design of SHSM also serves as a complementary to existing HSM devices instead of replacements. Its typical use cases include secure management of API credentials, secure handling of cryptographic secret keys and private keys, particularly those coming from base 64 or PEM encoded data, secure password handling through future server-side extensions or customized SHSM logic. Currently, due to SHSM primarily geared towards three stated use cases, the programming languages it supports are limited to modern C#, Java, Go, Python, Node.js, or TypeScript. Modern C# will be acting as the main core while the rest acts as clients. This was to mirror C language unsigned char pointer or uint 8 pointer. The client side has sudo and root privileges. Under all circumstances, sudo privileges won't have direct access to raw, private or secret key materials. There will be some sort of credentials involved in the process that will leave for future videos if I need to demonstrate the demonstration. It's called dependencies rely on Lipsodium and Bouncy Castle cryptography libraries. This particular logic that shows one of the proper and secure password and API key mechanisms can only be done in modern C# or C or C++. The actual demonstration will be left for future videos. It was in alpha stage and integrated with Arweave blockchain. The future plan include finishing and optimizing documentations, complete client-side demonstrations, and maybe adding FIPS 140-2 or FIPS 140-3 level 1 compliance. Needs huge funds and resources to do so. Here's the GitHub repository. I will also share the link at the video descriptions or pinned comment below. You guys can have a test run by relying on the data from test data. Any constructive feedbacks will be appreciated. That's all for now. Thanks.